Good morning, everyone. My name is Shai. Oops. And I'll be talking today about passage search. So first, a bit of introduction about myself. I work for IBM research for many years in the information retrieval domain. And I'm also a committer and a member of the PMC of the project for nearly 10 years. If you ever want to reach me out, then feel free to email me. And you can follow my blog, even though I don't update it very often. So who attended the general session this morning, or the pre-general session, when we had those trivia questions? OK. Who remembered the answer of how Mandalay Bay was called when it was constructed? Correct. So imagine that you wanted to build a question answering system. And in such a system, the user would come in, and he would type questions. For example, how was the Mandalay Bay called when it was constructed? And the system could provide an answer, like Project Paradise, or it could provide a more elaborated answer, right, like on the slide today. How would you build such a system? So first of all, this is a very complex topic to cover in one session, and I was only given one session to talk about. So let's talk at a high level first, and then I'll tell you what I'm going to focus about. So first of all, you want to understand the question. You want to extract the entities. You want to understand the meaning. And then you'll translate that into a query that you can send to your favorite search engine. Maybe it's Solr. Maybe it's Elastic. Maybe it's Lucene. And the engine will return documents that are most relevant to the question. But that is not the answer. So now you want to read the documents or analyze the documents to extract the answer from. However, usually the data set that you keep for question answering systems is very big, like Wikipedia. And therefore, there is a lot of noise in the documents. So trying to feed full documents to an algorithm that is going to extract one answer, like Project Paradise, is going to confuse the algorithm. So what we want to do is we want to focus the algorithm as much as possible. So instead of feeding full documents, we want to feed it smaller portions of documents. And which portion of the document are we going to extract? So if the query terms appear in some area in the document, it's reasonable to assume that the answer will be around those areas or close to them. So let's extract maybe the sentence or maybe the paragraph that the query terms appeared in, and let's feed that to the algorithm. So now instead of analyzing full documents, we are down to analyzing only a subset of documents. And therefore, the algorithm has a better chance of actually providing an answer because it has less text to process. And then the process continues because just by feeding portions of text to an algorithm does not come up with an answer. So you need to actually extract the answer, and I'm going to leave that aside. I'm not going to talk about this particular step in the algorithm. And in the session in the time that I was allotted, I'll talk about passage search. And those portions of documents in the literature, they are called passages. And I'll describe how we extract those passages from the text. Now, this is a very important step for many applications, and not just question answering. For example, if you wanted to provide evidence, you are given a list of claims, and you want to provide an evidence that support or contradict those claims. Then you also start by looking for passages in your corpus that mention those claims, and now you divide them into supporting and contradicting ones. Or if you are on a news website and you want to give the latest updates on Hurricane Irma, then you want to extract passages from news reports and then build a summary for a user that he can read what has happened with this storm for the past few days. So this is a very important step for many applications. And doing it right ensures that you can actually implement those applications on top. So let's start by defining the task first. Passage retrieval is actually a common task if you follow the track retrieval competition for search engines. There is a track that is called passage retrieval. And the task is defined as retrieving only the portions of a document that are most relevant to a user's information need. Okay, so let's read it backwards first. The user information need is the question or the topic that he would like to get a summary on, or the list of claims that he wants to get an evidence. So that is the information need. The portions of a document, those are what I defined as passages. And I want to make sure that we all understand a document is also a passage. It's just a very big passage. So actually, you want to return the smallest passage possible so that your application can then fulfill its goal. If it's one sentence, then it's one sentence. If it's a full paragraph, then you want to get back a full paragraph. And passage retrieval is about returning those passages. So unlike traditional search, where you submit a query and get back documents as results, in passage retrieval, you submit a query and you get back passages. And before anybody here asks, so why don't we index passages as documents and return them, and then we're done? Well, the problem is that we don't know what the passage is. Sometimes it's one sentence, sometimes it's a full paragraph, sometimes it's a full body of text. So you cannot pre-index only passages because you don't know exactly which of them will come back. Now, I will talk throughout this session, I will describe two approaches to extracting passages. And for that, I would like to introduce a passage. Okay, so if we could draw a passage ID card, then it would look something like that. First of all, it has the text. Obviously, we have to have a text in a passage. And optionally, we can also highlight the terms of interest in the passage. The passage has to know from each document it was originated and what was the document score, because as I said, we submit the query and we still get back documents, so they have a score. And we only get the top document, so you want to know that. We want to know the offsets of the passage within the document. We have to have a score for a passage, because then we need to rank passages and return the best ones. And there is an attribute that we call hotspots, which are the terms of interest in this passage. So the user submitted a query. We want to know where those terms appear in the passage, how many times they appear, and where in the text they appear, only in this passage. Okay, so I don't know if it pops into your mind, but snippets or search highlights, they are actually passages. Right? If you look at this part, right, this is a search highlight. When you send Solar a query and you ask for highlights, this is what it returns. It returns a bunch of text where the keywords of interest are highlighted. So now the question is, can we use highlights for passage extraction? Right? If you wanted to, how would it look like? So assuming that we use Solar, here is a typical request. I want to query, my query is Apache Solar, and I want to get back 100 documents. For each, I want to get 3 snippets. So snippets, highlights, passages, they are all synonyms. And each passage or each snippet, I want it to be of 500 characters in length. And so that my users will not get half words or half sentences, I also tell Solar, use a sentence boundary scanner. Right? So now the portions of text that I get are roughly 500 characters in length, potentially full sentences. Depends on the language and if we are able to do it right. Now, Solar is a very good search engine, and it faithfully executes this request, and it will return us with 100 documents and 300 passages. Sometimes it will return less passages if a document is not long enough to have more than to have 3 passages. But let's assume that we get back now 2 sets of data. 100 documents is one set, and 300 passages is the other set. Now the passage retrieval task is defined as returning the best passages. And by best passages, I don't mean let's return the top 10. I will show our evaluation where we evaluate the system at returning the best 5 passages. So for most of the applications that I mentioned, answering a question, summarizing a document, you don't want the algorithm to go through hundreds of passages. The answer is usually in one passage. Right? Summarizing documents, best would be if we could bring 5 passages that are unrelated, related to the topic, but do not overlap in what they cover, and stitch them together and call this a summary. So our task is to bring only the best and very few best passages. And now the question is, which of the passages do we choose? We have 300 passages. There is no order to the passages. How do we rank them? So one technique would be, Solr does not return random documents to us. It returns the best documents, and it returns them in a sorted order. So the top documents are the ones that best describe or are most similar to my query. So if we take their passages, somebody might say, okay, it's reasonable to assume that those are high-quality passages, right? But this is not always true. Because if I want to summarize news reports, and I pick 5 passages from the first 2-3 documents, then my user will not get much variance in the summary. It will get the summary of 2 news reports, which is not what we wanted. Now, Solr does not return also random passages. Actually, Lucene at the core computes a score for each of those snippets. And that's how it knows how to return the top 3. Now, the problem is that Lucene, Solr, and Elastic, they do not surface this score back to us in the response. And this is OK, because highlights, they were not meant for passage search. They were meant for placing in the web UI so that the user gets a quick indication of why this document was returned. But if we could tap into Lucene and extend somehow the highlighting process to surface this document, the score back to us, the question is, do we even want to use this score? Those snippets, they were ranked using global index statistics and document statistics, and this is not necessarily what we want to do when we rank passages. Maybe we want to virtually index passages in their own index now, all of those passages in their own index, so that we use only the statistics of those passages and not confuse it with the global terms index statistics. So it's not clear that we want to use that. OK, so now I'll describe how we extract passages or how we do passage search. And again, our goal is to start from a query and top K matching documents. This is Lucene and Solr. This is what we get. We submit a query, and we get back documents. And the question is how we transform those query and documents into passages. And we'll go through 4 steps, which are quite intuitive. The first one would be extracting passages from those documents. And then we'll want to fill this passage ID card with the statistics and the metadata. We might want to filter some passages that do not meet some criteria, and I'll talk about it. And eventually, the most important step is to score passages. Okay, in this session, I will focus a lot on the first 3 steps. And I'll talk about passage scoring as well, but not in great detail. Once we have that, and we have the passage ID card filled, then it's quite easy to sort and select the top 5, top 10 passages and return to our users. OK, so search highlights or passages. So first of all, we have to start by implementing passage extraction with highlights, because it would kind of be a sin not to try it. Right, so how would it look like? We get back from Solr a snippet, and the snippet looks like this. To our software, and remember, eventually this is software that we're talking about. This is just a blob of text. It does not know anything about this text. And the first challenge that we have is to understand the keywords in this text and what are the query terms that exist in this piece of text. Now, the snippet that we get back from Solr is not structured in any way. We don't get a score. We don't get a term vector-like structure for the snippet. And so the first thing that we will want to do is at least identify the keywords, the query keywords. And there is a problem with this. We don't necessarily know how the Solr instance that we interact with was configured. Does it do synonym expansion? Does it expand acronyms? Does it do automatic spelling corrections? The user might start with the question Apache Solr, and the engine will expand it into something much, much bigger, and I wouldn't even know about it. But Lucene at the core wants to return highlights that are useful for users to look in the browser. And one feature in the HTML is to be able to highlight some keywords. And when we ask Lucene, give me the 3 snippets, then we can define or we can specify the pre and post HTML tags that we want to use. So let's do that, and let's assume that I've asked Lucene or Solar to highlight or surround the terms of interest with the EM tag. Then it's very easy for me now to search for those tags in the snippet text and extract the tokens that I see there. And in this case, I will extract 3 unique tokens: Apache with a capital A, Solar with a capital S, and Solar with a lowercase s. Okay, now I will have many such passages, and some of them will have Apache with a lowercase a, some of them might have different forms of the same keyword, for example, like when you do stemming. And I want to be able to compare those passages. So I have to, if one passage says I have as a hotspot term A, then all variants of this term must exist in all other passages, otherwise they will not be comparable. But again, at the software side, I don't know, and I want to assume that I don't know anything about the Solar instance that I'm interacting with. So I sort of have to analyze those text, those keywords. And what does that mean? We need to feed that back into Solar through the analysis chain. Now, if you work at the Lucene level or maybe at the Solar plugin level, then you will have access to the analyzer object, and it's quite easy. Fortunately, Solar also exposes an analysis REST endpoint. And I also want to say that you want to use the search analyzer in this case. Because as I said, if somebody expands synonyms during search, they do not necessarily exist in the index or will not be returned to you in the indexing analyzer, so you want to use the search analyzer. And if you happen to use Elasticsearch, and I'm not sure if you're allowed in this conference, but if you happen to use them, then we didn't find a way to tell Elastic to analyze text with the search analyzer. So this is one downside of that. But anyway, let's assume that we can send our text to analysis, and now we get back those 3 tokens, Apache with a lowercase a. In this case, the analyzer was very simple. It only lowercases and white space tokenization. And Solar now is returned with, we get 2 Solars back with the lowercase s. And so we are able to complete the puzzle or complete the passage ID card. And we now can say that this particular passage has 2 hotspot keywords, Apache and Solar. Apache appears in 3 locations, and we can tell the offsets. And Solar appears in 4 locations. The one thing that I didn't say how you do with search highlights is how can you tell the offsets within the document of this passage. And again, this is information that exists in Lucene for sure, somewhere down below, but it's not surfaced to anyone back. And one way to do that is to fetch the stored field of the document and just look for the, if you're in Java land, then just do a text index of this passage text, and you get the offsets. So it's easy. And now we have a full passage ID card. And once we have a full passage ID card, we can score them and then pick the best ones. So question, are highlights the the approach that we should use? Now, it's not a tricky question because there is an image on the board here, and there's a plus and minus sign. So everything that we do in software has pros and cons, and there are trade-offs. So on the upside, highlights are already there. And what do I mean by that? As software engineers, we want to write as less code as possible, right? And extracting passages using highlights is almost 0 effort because it's a feature that exists in Lucene and Solar. You've seen the request that I sent before. It was very easy, and it's also done very fast. Lucene actually does a good service for us by returning only the top highlights. So if Lucene only returned the 3 highlights in order of appearance in the document, this would not be very good for us, and we would need to return all the passages or all the highlights. By returning only the best ones, then Lucene already does a great job for us by filtering most of them, and so we are left with even less passages to process. Now, there are some downsides to highlights. One, extracting the query terms, as I've shown. Yes, it's not rocket science. It's quite simple to implement, but it incurs an analysis call. Now, if you're at the Lucene or plugin level, then something that could be cheap. But if you need to interact with a remote Solr instance, and that Solr instance sits on an AWS server, then it's still an expensive call. And at the end of the pipeline, there is a user who's waiting for an answer or for a summary. So any second that we add to our processing hurts the user experience. Highlights are pretty much black boxed. They are very good, but they are black boxed. We are being given text. We cannot really tell Lucene, for example, I want you to return me up to 500 characters. But if there is a very, very, very good passage of 100 characters, I'm OK with that as well. We will get 500 characters, blocks of characters, using a sentence boundary scanner, so they are full sentences. But sometimes you want to get a varying length of passages from different documents. Now, there is something that is called a passage profile, which I didn't show on the passage ID card. So remember, the hotspots are only the terms of interest that exist in the passage. But there are scoring techniques, very good scoring techniques, that would benefit from knowing all the terms of the passage. So think about like building a mini index for a passage. And this is something that is very, very difficult to do with highlights because we are just given the text. So our only option at this point is to send all the text back to analysis. And if my passages are of length 500 or 1,000 characters, and I'm not just making up these numbers, I'm not going to work with passages of 20 characters length because most likely I will not find answers there. And I have 300 passages to evaluate, so that's analyzing 300,000 characters. Yes, it doesn't take minutes, it doesn't even take seconds, but it's at a time to our user experience. So can we do better, or is there an alternative? And again, this is not a tricky question because I said at the beginning that I will describe two approaches to extracting passages. So who here heard about term vectors? Indexes term vectors, good. So term vectors are like mini inverted indices for a document. When you configure Solr to index term vectors, then you will have this structure already in the index. And you can fetch those term vectors for documents. So let's see how we can build passages from term vectors. So assuming that we fetch the term vector from a document, it will look something like this. It's just a big table. Think of it as a very efficient hash table lookup. You can quickly tell which terms exist there, and once you know where a term exists or which term exists, then you know where it exists in the document. So our first step is to divide the passage into divide the document into virtual passages. I'm not yet concerned about filling the passage ID car properties. I just want to divide the document into virtual passages. And in this example, if the passage length is 1,000 and the document is 2,500 characters, then we will end up with 3 passages with an overlap and a window size. And we will have one between 0 and 1,000 characters, 900 and 1,900, and so forth. Now, this is an example of why passage filtering might be a step that we want to execute. So if this was a 2,100 characters document, then the last passage would be too small. And even if it's a perfect match for this query, this might not be useful for my task. If I want to build a summary, and then I don't want to give the user 5 words as a summary. This is not a very good summary. So sometimes, even if it's a perfect match passage to a query, I'll just want to filter it and forget about it. So our first job is filtering passages, those virtual passages that do not contain the query terms. Now, again, if you're at the Lucene level, you're pretty much like God. You can do whatever you want. But if you're at the client level, here you are a bit out of luck. Neither Solr nor Elastic have query parsing API that you can submit a query and get back the structure of the query, the full tree of the query. And this is a problem because at the client, we are only given the query text. And remember that the engine might execute a completely different query, and we would like to know that. So our only option is to analyze the query as if it was just a piece of text. again, using the search analyzer, in hope that if the query is simple, meaning it is not a fielded query, it is not a phrase query, not a range query, then the process actually works very, very well. Fortunately, in our use cases and our benchmarks, those are the queries, and users don't necessarily put in the, type into the search box very complicated queries. So this works well, but let's just accept this as a limitation in some cases and assume that we know the query terms for now. This is very good in research. Sometimes you just assume things, and you proceed without actually solving the problem. So now we can filter passages that do not contain the query terms. And we are left with two passages that we are sure that either all or some of the query terms exist in them. And it's quite easy for us to fill the passage ID card. Right? So the document ID is given to us. The document score is given to us. The offsets within the document, we've built those virtual passages, so we know exactly the offsets. The hotspots are very easy to fill. The only tricky part is how do you build the passage text, but this is not very tricky. Again, fetch the stored field and extract the subset or the portion of the document that correspond to those offsets. And this is pretty much how the fast vector highlighter works, by the way. So I'll ask the same question again. Are term vectors good enough? And yes, it's the same picture because there are pros and cons again. So pretty much flip the pros and cons of highlights with term vectors and you get a full picture. On the upside, term vectors give you full control. I wrote here more control, but it's actually full control. You are being given the best data structure to work with when you talk about indexing and search. A term vector is a mini index. It's a mini inverted index of a document. So you pretty much can do whatever you want with it. Building the passage profile, meaning filling in some table all of the terms within the passage, is that simple because the term vector contains all the terms. Detecting the query terms in terms of complexity, assuming again that we know that the set of terms that comprise the query is an order of one. It's just a simple lookup in a hash table. So term vectors are very good for that. But term vectors have some downsides too. As software engineers, we want to write less code. Less code is good. But the term vector approach is not a capability that exists in Solr. The term vector itself is, but constructing passages isn't. If your Solr instance is remote to you, then term vectors are much more expensive than highlights. So even on this machine, local host to local host communication, searching for 100 documents in 3 snippets is twice as fast than fetching the term vectors for 100 documents. When your Solr instance is on an AWS server far, far away from you, then the difference grows dramatically. And if we ever need to support complex queries like phrases, and it's not that highlights do a great job at it, but here we would have to actually implement this logic again. So it's something that we want to avoid. So I've shown two approaches to extracting passages. In both of them, with some limitations, and sometimes we need to work harder than another approach, but we were able to fill the passage ID card minus the passage score. How am I with the time? And so now I want to talk about scoring the passages, because if we are not able to do a very good job at scoring passages, then eventually whatever we return will be garbage. If the answer that we return if the answer that we look for is not in the top passages, then we will just not be able to return an answer. So let's very briefly talk about scoring passages, and why briefly. There's a lot of theory behind all of those techniques, and I could spend at least a session on just the scoring techniques. And there are many formulas and many papers written on those, and I don't want to bore you to death. So I'll just go over them very briefly. A passage-only approach is taking or scoring passages just by the appearance of query terms in it. So just like we sometimes score documents, we just look at the document and the query, and just look for statistics of those query terms and enter an index. Maybe if you are familiar with the TF-IDF similarity or the BM25 similarity, they are very simple similarities. So that is a very simple technique. But sometimes you want to do something more sophisticated. You want to build a language model for the passage, and for that you need to know all the terms of the passage. Or you want to build a relevance model that takes the query into account and the language model of a passage, and then you can do a better comparison between passages. And sometimes you want to extract entities from passages. So there are many ways to score passages. There are obviously pros and cons to each one of them. Not all of them work great in all scenarios. But let's assume for now that you've selected one technique, and you go with it. Okay. Now, how we evaluated our work. So I had to say that we score passages because we had to select the best ones, and I'll be happy to elaborate, after the session on each of these. But let's just forget about those for now and assume now that we are able to score passages. So how do we evaluate such a system? So we built a benchmark that can index a lot of data sets and take some queries as the benchmark. And this is how the benchmark runs. So specifically, we index Wikipedia, and we have 1,517 questions, natural language questions, that human judges wrote, accepted answer patterns, that is regular expressions. So these are special humans. They actually know how to write regular expressions. And our evaluation criteria is very simple. It was for a question answering system. So the evaluation criteria was, does the passage include the regular expression? Obviously, if a passage does not contain the answer, then there is no way for the system to provide an answer. Right? So if the passage contained the answer, at least on our side of the job, extracting passages that are good for this question, we've done a good job at it. And we compute two measures for it, match at k and precision at k. Very briefly, I'll say match at k is, or match at 5 means, do I have a relevant passage, meaning a passage with the accepted answer within the first 5 passages? And precision at 5 means how many passages of the first 5 are relevant or have those. And I compare between highlights and term vectors, right? And we see that they are very similar to one another. Actually, it depends on the scoring technique. Sometimes the term vectors is slightly better than the highlights. And as I said, especially for the language modeling stuff, term vectors are currently the only option to go with. But all in all, they are very good, both of them. So let's evaluate those two not only from a quality perspective, because we build actual products and we have actual users. So there are 4 categories that I'll go over. Quality, they both get a check from me because they are both very good and they are comparable. So that's good. In terms of effort and complexity, highlights definitely win. Much less code required to achieve our goal. In terms of capability, term vectors win here because term vectors give you, well, you work at a very low level structure that you can implement pretty much whatever you want. In terms of speed, there is a check and a check with an asterisk. So highlights are very fast. And well, Lucene is very fast, and Solar is very fast, and it's all very fast. But term vectors are very slow, unless you work at the plugin level. So if you intend to implement passage retrieval as part of a Sora plugin, then you would access the same data structures as the fast vector highlighter accesses, and therefore you will be more or less the same speed with the highlighter. So I would say if you have to use Solar on a remote site, then highlights are your best friend. But if you have to have term vectors because you want to do language modeling, scoring techniques, and you have to use term vectors, then at least make sure to either write a Solar plugin or to collocate your client with the Solar instance as much as possible. Now, I covered what passage retrieval is and also the 2 techniques on how to extract it, and I hope that you all feel now that you are ready to go and implement this and it's not rocket science. And I've shown that both of these approaches are pretty much comparable, and they are very good. And I think I'm about to run out of time also. So I'm ready to take some questions if you want. Yes. How much time do I have? Yeah, I think we have time for 1 or 2 questions. Yeah. Yes?
Slide 11, I didn't get how do you reconstruct passages or full sentences from TF-IDF? How do you reconstruct a full sentence from TF-IDF?
From the term vector?
Yes.
Okay. That is part of the custom logic. That is one of the drawbacks. So the question was when you use term vectors and you want to construct the passage's text, then yes, extracting the offsets of the text is easy, but you want to construct full sentences. Right? So this is the part of our custom logic that we've implemented. We actually use something that is very similar to how Lucene does it. We use Java's break iterator. Okay, so we just take the piece of text and then go backwards until we hit the end of the previous sentence, and then we go forward until we hit the end of this current sentence. Okay? One other question? Yes?
Have you ever done any work with Stanford?
Sorry, I didn't.
Have you ever done any work with Stanford NLP program?
Yes. So the question was, have I done any work with the Stanford NLP program? First of all, personally, I haven't. But I also know that it's not a very good library. It's not a friendly library for us because it's a GPL. And this pretty much kills the idea of trying to use it. So, but I don't want to talk too much about it. Yeah, okay, good. Let's go ahead until people interrupt us.
You proposed this as the highlighter versus term vectors. I guess this is at a high level 2 approaches. Either I'm going to ask Solar to highlight, or I'm going to ask Solar for the term vector. I'm going to do a lot of work on the client side that Solar would normally do in the highlighting phase. I guess another path that I would take, based on my own biases and my own experience, which would be maybe starting off with highlighting, and then when I want the control that I eventually want, but maybe not want up front, maybe I want to prototype up front. So eventually what I want the control is being the ability, because we're working on an open source platform with Lucene Solar, being able to extend and hack the highlighter in Solar.
Yes.
I know for a fact that the Solar unified highlighter and Lucene underneath it are very hackable.
Right.
And extend it and convert it to do interesting things like this.
So the question or the statement and the question hidden in it is, can we use a third approach, which is extending the highlighter to implement the custom logic that we've done with the term vectors? And this is a very good question because the answer is definitely yes. Why we didn't do it? Because we already had the term vectors approach implemented. But if you are able to extend the highlighter, then you can reduce some work or some code from your term vectors solution. Now, one thing that is maybe unique to us, but I don't think it's only us, most of our Solar and Elastic instances are on the cloud. And one drawback of putting these two in the cloud is that some of the control is being taken away from you, and you are not allowed to upload your custom plugins or your own code into this Solar instance. So we had to implement a solution that works for most of our users right out of the box. Okay, now I think I have to finish. Thank you.